Every now and then, the unthinkable happens. It could be as simple as a kink in the brake pipe or a closed angle cock. A situation arises that calls for emergency braking. The air brakes don't respond properly, and what started out as a routine run ends up in disaster. That wreck might have been avoided if the train were equipped with a two-way telemetry system. Without it, the engineer had no way of initiating an emergency brake application from the rear of the train. As you learned from watching the EOT overview video, the FRA two-way telemetry law is in full effect. Two-way telemetry does improve the safety of our railroad. And when proper procedures and guidelines for maintaining and operating EOT systems are followed, it won't slow us down. The FRA mandates that trains traveling over grades of 2% or more for 2 continuous miles, or that exceed 30 miles per hour, must be equipped with an armed and operational two-way telemetry device, except for the following examples. Trains capable of making an emergency brake application through a crew member or a remotely controlled consist that is in radio contact with the lead locomotive and located in the rear third of the train. Trains operating in push mode in radio communication that are capable of making an emergency brake application from the rear of the train. Trains with manned cabooses or shoving platforms in radio communication that are capable of an emergency air brake application. Trains with a fully independent secondary braking system that is capable of stopping the train in case the primary system fails. Trains that only operate on tracks that are not part of the general railroad system. Passenger trains with emergency brakes. In addition to the exemptions you just heard about, work and local trains with 4,000 trailing tons or less are exempt from the two-way telemetry laws. If these work and local trains are traveling over grades which are 2% or greater for 2 continuous miles as defined in special instructions, they must be equipped and armed with two-way telemetry, or meet one of the criteria we just discussed. So as you can see, the vast majority of our trains have to be equipped with the two-way EOT devices. And in order to meet our commitments to our customers in a timely and efficient manner, CSX employees need to know how to service and operate these systems properly. The EOT installation and arming procedure begins with the yardmaster or mechanical department employee who assigns an EOT to a particular train. If the system has already been bench tested at a prep facility, the ideal situation, the locomotive engineer must be notified that the bench test has been completed successfully. If it has, install the EOT unit according to the procedures outlined in your support materials and the EOT overview video. At the point of installation, the EOT system can be armed by 2 qualified employees, one at the rear end and one at the head end of the train. Remember to hold a job briefing before beginning this task, enabling the head end person to be in position to press the communications test arm button within 5 seconds. The first step in arming any EOT system is to push the EOT test button to activate the device. Next, establish communication with the head end person using proper radio procedures, and inform that person of the EOT identification number. After charging the air brake system, an accuracy check of the air brake pressure is required. Head of train and rear of train pressure cannot vary by more than plus or minus 3 pounds. On the CW44AC, CW60AC, and SD70AC locomotives, the EOT systems can only be armed and disarmed through the locomotive's computer screens. If you're arming a system on a CW44AC, begin at the main operating screen, which will display a series of zeros in the lower right corner. Press the F3 key to get to the operator function screen, and then press F3 again to get to the EOT setup screen. Use the F1 through F5 keys to input the correct EOT identification code, then press F6 to enter the code. The person at the rear of the train will press the test button of the EOT, causing the Arm Now message to be displayed in the status text. Press and release the F7 key on the computer screen within 5 seconds to complete the arming procedure. The status text should read, Armed. When arming a CW60 AC, start at the main operating screen, which will read 0000-0 on the lower right corner. Press the 2 key to display the end of train screen. Press the F3 key, then use the number keys to enter the EOT identification code, then press F7 to save it. After the ID code is saved, the screen will change back to the EOT setup screen. When the person at the rear of the train pushes the test button of the EOT, the status text on the computer display will read Arm Now. Press and release the F7 key within 5 seconds to complete the arming procedure. The status text should read Armed. To arm the system on an SD70 AC, start by pressing the EOT Ident button. Then enter the EOT identification code and press Enter Ident. The screen will display System Unarmed. When the person at the rear of the train pushes the test button of the EOT, the COM test label changes to Arm Now. Press the Arm Now button within 5 seconds and the EOT status text should change to EM Enabled. If you're using an HTD direct unit, the EOT identification number is dialed into the HTD. The person at the rear will push the test button of the EOT, which will cause the Arm Now message to be displayed on the message display of the HTD. The engineer must then press and release the Communications Test Arm button on the HTD within 5 seconds. If the arming procedure is successful, the ARMD message will appear on the HTD display. The system is now armed. Remember, no matter which device you're using, when the person at the rear of the train pushes the EOT test button, the engineer must respond by pressing and releasing the appropriate button on the HTD within 5 seconds, or the system will not arm. If the test does fail for any reason, wait at least 20 seconds before attempting the procedure again in order for the system to clear its memory. When 2 or more locomotives are present on a train, make sure that only the lead locomotive's HTD is armed. If a trailing locomotive's HTD is armed with the EOT identification code for the unit at the rear of the train, the HTD on the lead locomotive may not arm. The HTD should have already been tested by a locomotive service center, and the EOT device should have already been bench tested by a prepping facility before it's installed on an outbound train. If for some reason the unit has not, and there is not another EOT available that has been bench tested, the EOT emergency braking system must be tested at the point of installation on the train. This procedure is accomplished as follows. Charge the train air brake system to proper pressure. Close the angle cock between the last car and next to last car from the rear of the train. The engineer or qualified person will then activate the emergency feature from the controlling locomotive. The employee at the rear of the train must then ensure that the brakes apply in emergency, and the locomotive engineer checks that the air pressure reading on the HTD reduces to 0. After the test is completed successfully, the angle cock must be opened and checked to make sure air pressure is restored. There has been some confusion as to how to proceed when a train leaves the yard with a properly operating EOT system and then experiences problems during the trip. As you learned in the EOT overview video, there are only 5 situations that constitute an FRA en route failure and require immediate corrective action. If the emergency brake application from the rear can't be initiated, an error message indicating a front-to-rear communications failure appears. A dead battery message appears. An emergency air valve circuit failure message appears. If the HTD unit is not armed. Let's take a look at the FRA en route failure messages for the 4 HTD display systems. On the CW44AC, EOT COM indicates a front-to-rear communications failure. EOT BAT indicates a dead battery. EOT valve indicates an emergency air valve failure. On the CW60AC, EOT FR-COM indicates a front-to-rear communications failure. EOT BAT-D indicates a dead battery. EOT valve indicates an emergency air valve failure. On the SD70AC display, FR-NOCOM indicates a front-to-rear communications failure. Dead BAT indicates a dead battery. Valve fail indicates an emergency air valve failure. On HTD direct systems, FR-NOCOM indicates a front-to-rear communications failure. Dead BAT indicates a dead battery. And valve fail indicates an emergency air valve failure. If an en route FRA failure does occur, the speed of the train must be reduced to 30 miles per hour unless it is a local or work train with 4,000 trailing tons or less. In addition, the train will not be permitted to operate over a section of track with an average grade of 2% or more over a distance of 2 continuous miles until corrective action is taken. A manned helper or caboose coupled to the rear of the train that is in direct voice radio contact with the lead engineer will permit the train to operate over those 2% grades at normal speed. If a front-to-rear communications error message appears, try pushing the Communications Test arm button to re-establish communications. In addition to the en route failure messages, there are other error messages that may appear on the HTD. These messages are not considered en route failures and do not require that the train be slowed to 30 miles per hour. A rear-to-front error message is not considered an FRA en route failure. A weak battery message is not considered an FRA en route failure. An intermittent communications failure is not an en route failure. The train must have a continuous loss of communication for at least 16 minutes and 30 seconds, triggering a front-to-rear communications failure to experience an FRA en route failure. Trains that experience en route failures or experience a low battery signal on the HTD must notify the train dispatcher or mechanical desk immediately. Because armed EOT devices continue to transmit even though the train may be separated, they must be disarmed when cutting from the train. Disarm the two-way telemetry by using the following procedures. For direct HTD units, set the HTD code thumb wheel switches to 00000. Press the Communications Test arm button. The system is now disarmed, and the HTD will display DIS-ARMD. For CW44AC locomotives, press the F6 key. The EOT status will then read disarmed. Press the F7 key, which will read disarm two-way. For CW60AC locomotives, modify ID code to 00000. Press the F7 key to disarm. The EOT status should now read disarmed. For SD70AC locomotives, modify EOT ID code to 00000. Press the unarmed two-way button. For further information and instructions, refer to your locomotive engineer's toolbox and other support materials for CSX transportation two-way telemetry requirements. Understanding how to effectively operate the EOT two-way telemetry systems is essential for the safety and productivity of our railroad. Remember, the future of CSX transportation is our future. It's up to us.